Hello learners, welcome to this course on practical machine learning using Google Colab. In this tutorial, I will be discussing about on how to perform a text classification using Tensorflow API. So the code related to this program is available in the GitHub repository as given in the link below. So here in this program, we are going to do text classification using Tensorflow API. So I am going to take a IMDb dataset. So Internet Movie Review dataset which contains about 50,000 movie reviews. So out of 50,000 movie reviews, we are going to consider 25,000 for training and 25,000 for testing. So each data in this movie review dataset is classified either as a positive review or a negative review. So a label of 1 represents a positive review, a label of 0 represents a negative review. So this data set is considered to be balanced data set because we have almost equal number of positive and negative reviews. And we will be also using a Tensorflow Hub for converting your text into vectors. So that is the initial stage before the classification happens. So we will be making use of a Tensorflow Hub as a transfer learning method to convert your review into the vector format. Now let us move on to the program. First, let us get connected to the Google Colab environment. So in order to get connected to the Google Colab environment, you have to set the notebook settings. Go to Edit, Notebook Settings. Here you can select the type of hardware you want to use for this application. Once you selected, get connected to the cloud environment. So once this is done, let us start executing each cell in our Google Colab environment and try to visualize the output. So here first, in the first cell, we try to import the packages which we require, like print functions, Unicode literals, etc. Same way, matplotlib is used for utilizing a Python plot. So instead of using a pyplot, we will be in short form using it as PLT. Then we try to import a NumPy, which is a numerical Python library, which is mainly used for processing your matrices and vectors. Then we try to import the TensorFlow library, which is a package required for building and deploying your machine learning models. So instead of using TensorFlow in our program, in short, we will try to use it as TF. Then we try to import the pandas library, which is a high-level data manipulation tool, which is required for our program. And as I said earlier, we'll be making use of a transfer learning technique to convert your text into vector format. For that, we'll be making use of this TensorFlow Hub. So in short form, we will be using it as Hub. Then the dataset, IMDb movie review dataset is available in TensorFlow datasets. So we try to use it as TFDS. So let me run this cell. So all the packages will get imported to the program. So now let us check the version of TensorFlow. What is the version? Using this tf.__version__. Then I am going to check whether the TensorFlow is working in a eager mode. So eager mode is something like a code will be used for generating a graph, and that graph will get executed whenever we provide the inputs. So eager mode is something like instead of generating a graph and using it for our program, immediately the data will be sent to the program and the result will be updated. So we also try to see what upversion we are going to use, and we are going to check whether GPU is available or not. So here you can visualize. So the version, TF version is 2.9.2, eager mode it is true, and the hub version is 0.12.0 and GPU is available. So now let us get the data from the TensorFlow datasets. So from TensorFlow dataset, I'm going to use the load function to get the IMDb underscore review dataset. So it contains about 25,000 training reviews and 25,000 test reviews. So in that training reviews, I'm going to divide it as a training data and a validation data. So 15,000 reviews, I'm going to use it as a training data, and 10,000 reviews, I'm going to use it as a validation data. So I divide the training data. So training in square bracket, I put colon 15,000, which means from the starting review till 15,000 the review, it will be taken as your training data. Then the next set from 15,000 to the last, colon to the last, which means the remaining 10,000 in the training data, we try to take it as a validation data. And in the test data, we take all the 25,000 as a test data. Then we use a batch size of -1. So batch size of -1 represents the data which we get from the data set will be in terms of a TensorFlow tensors. So tensors are nothing but multi-dimensional array of elements. And we specify as supervised is equal to true, which means each data will be associated with the labels. So that is how the data will be retrieved, and it goes into the training data, validation data, and test data. So the training data initially 25,000 is divided into 15,000 for training data, 10,000 for validation data. So 20,000 data in test data is available in test data. So now we convert this TensorFlow tensors into a NumPy array. So NumPy array is obtained using this tfds.as_NumPy. So we convert the TensorFlow tensors to a NumPy array. So in training data, validation data, test data, everything we try to convert into a NumPy array. Then we try to print it and see how many such training examples are there, validation examples are there, and test examples are there. So when I run this, you can see the data is getting downloaded. So now you can see that in training data, we have about 15,000, validation entries 10,000, and test entries 25,000. Now let us look at some of the examples. So in training examples, I am going to take the first 10 examples. So let us see how it looks like. So when I see here, so this is the first review. This is the first review. So this was an absolutely terrible movie. Don't Be Lured In by Christopher Walken or Michael Ironside. So some person have given the review regarding a movie. And what does this movie represents, whether it is a good or bad? So that will be represented by a label. So here we try to take the 10 such examples, first 10 such examples. This is the first example, second example. So like that it goes on. So we have 10 examples. Let us look at the labels associated with each of these reviews. So train underscore labels 10. So which means the first review is a negative review. Second also is a negative review. Third is a negative review. Fourth one is a positive review. So the label of 0 represents a negative review. A label of 1 represents a positive review. So that is how the data set is available. So we have a review for a movie, and we also have the associated labels, whether it is a positive review or a negative review. So once we have taken the data set, let us consider building a model. So in order to build a model, the first step is we need to have our data in terms of a number format. So we have initially the reviews in the text format. We want to convert this text into a number or vector format. So how to represent the text? That is the first query which we need to address. Then how many layers we need to use in the model? if I use a neural network, how many layers I should use, and how many hidden units in each layer we should use. So these are the questions we should answer while building our model. So now let us consider taking a pre-trained model from TensorFlow Hub, which is available in this location. So this already developed transfer learning method, when I give a text information to this model, it will give me a vector coming out of this transfer learning technique. So it will get converted. The text input text will be converted and it will be formed as a vector. So we don't need to worry about the text pre-processing. So we can take advantage of this transfer learning technique. Instead of doing it from scratch, we already have a transfer learning technique where when we give an input text, it will be converted into a vectors. So here we have multiple dimensions. So here this model is going to give me an output of 20 dimension vector. So whatever might be the text, however long it can be, so the output will be a 20 dimension vector will be returned. So now let us first initialize this embedding layer. So this embedding layer is available in this location. It is already trained model. So we try to initialize this embedding layer. Then try to use the hub.keras layer where we give this transfer learning model, and what should be the output? Our output should be a 20 dimension vector. The input can be a variable length vector because one review can be short and another review can be long, so it can be varied. So we need not worry about that. So our input shape can be varying, but my output shape, the output from my embedding layer should be a 20 dimension vector. So we try to initialize this, then try to apply this model to our training examples. So let us take 3 examples. So I am going to take 3 training examples and give it to this hub layer. Let us see how the output looks like. So when I run this, you can see the 3 examples. Initially I have showed the review. It's a very lengthy review. So you can see as an output of this hub layer, so this is the 20 dimension vector for the first review. So in each row I have 4 elements. Sorry, in each row I have 5 elements. So total 4 rows, 20 elements are there. Same way, this is for the second review and this is for the third review. So our text got converted into a number format of fixed dimension using the embedding layer. Once this is done, we can easily give this vector into our neural network. So now let us create a model, neural network model. So I am going to initialize tf.keras.sequential model. Then first layer will be our hub layer, which is going to convert your text into a 20 dimension vector. Then I am going to have a hidden layer, which is a dense layer with 16 neurons in it. Okay, hidden layer with 16 neurons in it, and the activation function is ReLU activation function. So ReLU activation function stands that whenever I have a positive value, it will be retained, whereas a negative value, it will be given as 0. So then I have an output layer. So output layer, it is something like a binary classification, positive review or negative review. So I have one neuron and it is given with an activation function of sigmoid activation function. Then we will have a model summary. So when I build this model, you can see the first embedding layer, it has about 4,0,0,0,20 parameters are there. Then in the hidden layer, I have 16 neurons. So the output shape from the embedding layer is 20. So this 20 into 16 plus 16 parameters for the bias term. So it comes about to be 336 parameters. And then in the final output layer, I have one neuron. So 16 into 1 plus 1 bias term, it will be equal to 17 parameters. So altogether, we have about 400,373 parameters to be trained. So after building the model, we have to initialize the parameters for the model. So initializing the parameters is done by model.compile function. So here the important parameter to be set is optimizer. how this weights and biases will be updated. So we have different optimizers like Adam, Ada Delta, Ada Max, etc. So I'm going to use here Adam optimizer. Then a loss function, since it is a binary class, we are going to use a loss function of binary cross entropy loss function. So by calculating this loss function, the weights and biases will get updated. And the metrics which we are considering is accuracy. So once this is done, we are going to train the model for 20 epochs. So 20 epoch in the sense, a complete data set will be given to the model for training. So that is considered to be 1 epoch. So if I give the complete data set for 20 times, then our model will be trained for 20 epochs. So model.fit function is used to train the model. So I give the training examples, training labels, training data as well as labels are given, and we select a batch size of 512. So the weight updation will happen for 512 data. And how many times we are going to expose the data set? For 20 times we are going to expose the data set. And we are also going to check how well our model has learned after each epoch. After each epoch, I am going to provide the validation example and validation labels so that I can check how well the model has learned. So the output of this training function will be saved in the history variable. So it will get executed. So you can see right now the first epoch. So you can see a batch size of 30, which means in the training data, I have 15,000 training examples. So 15,000 divided by 512, it comes approximately 30 batches. So for 30 times in one time exposure of a data set, weights will get updated. So you can see a training loss, training accuracy, validation loss, and a validation accuracy. So this will run for 20 epochs. So when you look at it, you can see the training loss, initially it was 0.8684. So it keep on reducing. As the number of epochs increases, you can see it keeps on decreasing, which means that the training accuracy is keep on increasing. What happens to the validation loss? You can see validation loss is also decreasing and the validation accuracy is increasing. So we can visualize it. Then now let us evaluate the model by putting the test data and test labels. So when I run this, you can visualize a loss of 0.325 and accuracy of 86% is applied. So now let us plot this and visualize. So in order to plot, so as I said, when during training, we have the history object. So the history object, from that I try to find the keys. What are all the important keys? So keys are nothing but loss. This is training loss, training accuracy, validation loss, and validation accuracy. So let us assume, let us put this keys into some variables. So in the history dictionary, I am going to take the accuracy parameter, put it onto variable accuracy. Same way validation accuracy, I am going to assign it to validation underscore ACC. Loss, I am going to assign it to loss. And validation underscore loss, I am going to assign it to validation loss. Then let us plot and see. Using Python plot, let us plot and see between epoch and loss function. Same way epoch and validation loss function, I try to give different colors for the parameters. So let us run and visualize it. You can see as here along x-axis we show the epochs. Along y-axis we have the loss function. So this dotted line represents the training loss. This continuous line represents the validation loss. So here you can see both losses keeps on decreasing. As the number of epoch increases, both the losses keeps on decreasing. Same way, let us visualize the accuracy also. Epoch versus accuracy, which is a training accuracy. Epoch versus validation accuracy, which is a validation accuracy. So let us plot this one and visualize. Both accuracies are increasing. This dotted line represents the training accuracy. Continuous line represents the validation accuracy. So here you can find one thing. So after certain epochs, your training accuracy keeps on increasing, but the validation accuracy, it is not increasing significantly with respect to your training accuracy, which means there is a gap increasing between the training accuracy and the validation accuracy. So this represents a overfitting of a model. So when the model is run for more than 10 epochs, what happens? It is overfitting. It is getting overfitting. So it is trying to learn very closely the data. So it will work really well for the given data, but when it is exposed to some new data, it might not work well. So this condition is called as a overfitting of a model. So this should be avoided while training purpose. So this can be avoided by different methods like stopping our training. Once we find the deviation between the training accuracy and validation accuracy is increasing, we can stop the training process. So that is one option. Or we can use some regularization methods, L1 regularization, L2 regularization. Thereby we can avoid this overfitting of a model. Or we can use some dropout layers. So thereby the overfitting can be avoided. So I will discuss about these different methods in the coming tutorials. So in this tutorial, I have discussed mainly about how to perform a text classification using Tensorflow API. So here we used a Tensorflow Hub as a transfer learning technique for converting your text into vectors and give that vector into our neural network model. Then we try to see how the loss and accuracy varies with respect to epochs and how to identify a model overfits or not. So that is what we have discussed in this program. So thanks for watching. Please subscribe for more technical learning. So you can find the code of this tutorial in the following GitHub repository. Thank you.